we're still green and we're still go here. 10 minutes to go. Mosfa's appointment effective on the 3rd of this month. He joined Kinetic. Why do we have to do this so close to launch time?
Well, when the launch vehicle was on the launch pad, it had to be sheltered from outer elements and stayed, including during the integration of the upper composite, under the gantry. Now we have to remove this gantry in order to proceed with the cryogenic filling of the upper stage for hazardous, which is a hazardous operation. And we can do that provided the wind is below 17 meters per second, which is the case today. And these gantry will stay on the side of the launch vehicle right up till liftoff.
So the gantry is withdrawn from the launcher. The launcher is not pulled out of the.
That's right. It's a gantry that rolls back.
All right. Now we had at 10 minutes while you were watching those shots, we had the last weather check before launch, and what did they? You mentioned that the wind is under 17 meters, so we're favorable for the weather tonight. No problems.
Well, we have two types of weather conditions. Some of them are related to the launch vehicle itself, that is wind on the launch pad, and also the lightning criterias. Both of them have been reported green, whereas we have other criteria related to the safety of people and goods in the country. And these are, so to speak, altitude winds and what we call the wind on the beach, and also a possible heavy rain if that would alter the visibility of the launch vehicle in the first 300 meters. And all these criteria are green. This is a map of the meteorological situation as the latest one as we can see today, and you can see in the Guyana is Kourou is at the bottom of the east part of the map, and it's clear.
So we're okay. Now it was raining the latter part of last week, and we've had a couple of sunny days, and like we say, the wind came up a little bit in the afternoon, but apparently nothing to worry about.
Here, Bernie Beanstalk and Art Rosales on the left, and Brian Benedict with his brown helmet. Here, Doug Kahn from PanAmSat is a president and chief executive officer of PanAmSat. Apparently very relaxed. So the operational customers team is more concentrated on what's going on, obviously.
Now the satellite team's also relaying their information into the DDO about their Brian Benedict with the We're going to come up on the 6-minute mark, and you'll hear the DDO call out 6 minutes, and you'll hear him say something like séquence synchronisée, synchronized sequence, or also called automatic sequence. And this is the final stage of the final countdown. There are the green boxes that we were discussing. Météo on the bottom is weather, Galaxy in the middle is the satellite, on top lanceur is the launch vehicle, ensemble de lancement is the launch vehicle.
À tous de DDO, attention pour le début de la séquence synchronisée. Top, H0 moins 6 minutes.
All right, we are into the synchronized sequence, also called the automatic sequence. What's happening is the computers are taking over now, and power is passing, as I understand it, from the ground to the launch vehicle?
Yes, so we have several steps that happen up till now in the earlier phase of the chronology that started on Saturday with filling the first stage. Operations were conducted in manually. And now at -6 minutes, we have two computers running parallel programs.
And the computers are up here at the launch center.
And these programs are led in parallel, one for the fluids and gases, liquids, the other for electrical systems. And both of them have to meet some rendezvous at very precise times, and these two computers are going to run the sequence right up till liftoff.
And they're checking out all the verifications and confirmations vital to the mission's success and safety. Every launch, of course, a very complex affair, and Ariane Space wanting to make sure that everything is just right. Before we go farther with that, take a look at the bottom of the launcher, those flames, just to reassure everybody the launcher's not on fire.
Yeah, this flame is, in fact, a flame that comes up here as a control center with people in charge of preparing the launch vehicle. And as you see, even though we're on the automatic sequence, they have some information report.
Right, so what about the...
We come back to this flame. This is the flame coming out from the burn pond where we burn the boil-off hydrogen, which is in the upper tank, and that continuously vaporizes. And we have to evacuate that.
But it's not on the launcher. It's behind.
It's behind the launcher at a safe distance, yes.
All right, so what's going on is the computers, these two computers, one for the fluids, as Jean-Marc mentioned, one's for the electrical system, which are located here at the launch center, which is, by the way, 13, 14 kilometers to the northwest of where we are here in Mission Control. They're doing the last safety checks and authorizing final...
And with the spacecraft now.
All right, you saw the cameras zooming in on this cryotechnic arms, also called the propellant feeder arms. These are the arms feeding, we mentioned, the cryogenic liquid hydrogen and oxygen into the third stage. And the shot is important. We wanted to take just a minute because it's the last thing you're going to see before liftoff. In order to have liftoff, these feeder arms, which are feeding the fuel into the third stage, will stop feeding the fuel when we've topped up, and these arms have to swing open. And if we don't get arms swing open, we don't have liftoff.
As a matter of fact, the filling is completed now, but we still have some final pressurization that all go through those connectors. And from the time these have to open at -5 seconds in the sequence, and of course if they wouldn't open, that would be an aborted launch. But if they open, then the launcher can go.
Now what you're going to see is when the feeder arms open, there's an interesting ignition sequence, which we want to spend a moment on as well. Daniel Mounier on the left, who's the...
is a technical authority of Ariane Space, and Jacques Rossignol, the chief operating officer, and Jean-Marcel Agasse, which is operation director. These three people are representing the flight authority, and Jérôme Paolini, the
who
head
is
of
VP for International Affairs and Corporate Communications. Now we started to mention, yeah?
So here we have Randolph Brinkley, the Executive Vice President of Use, and Robert Bednarik, Executive Vice President and Chief Technology Officer of PanAmSat. And
all right, coming up under the 2-minute mark, we just want to get you up to speed on the ignition sequence because it's rather interesting. At H0, the motors on the first stage, the 4 of them, are going to be lit. But we don't have immediate liftoff after ignition. What do we have? We have these same two computers that you were talking about checking out the fluids, are going to check out pressure in the engines.
Okay, so then, as a matter of fact, the 6 engines ignite. They take about 2.5 seconds to build up pressure and thrust, and then we have another 2 seconds during which the computer check the parameters are correct in the combustion chamber. And then that's only will authorize the hooks that hold the launcher down on the table to open.
So the launcher is held down to the launch
by 4
table.
hooks, yeah, that's right.
Which the computer...
À tous de DDO, attention pour -1 minute.
DDO going to call out the 1-minute mark now.
Top,
and we hope you'll enjoy the launch, everybody.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage. Décollage. La propulsion est normale.
All right, you see all the engines burning away there.
Le pilotage est normal.
The four main engines and the two boosters. The DDO says that guidance is all nominal. Speed is nominal. Ariane, when she's lifting off with this version, weighs roughly 1 million, that's 6 zeros, 1 million pounds.
Correct, and it's powered with this 6 Viking engine, as you have seen, that function flawlessly. So now this first part of the trajectory was vertical ascension, followed by a tilting movement toward the east, and as you can see that on the trajectory.
We didn't see because we have cloud
but you
cover.
can see it here on the trajectory.
On the left-hand side.
It was accompanied by a roll movement in order that the antenna of the launch vehicle could get a proper transmission to the receiving aerial, which is located on the Kourou station.
We didn't see that either. But what you can see is the cursor on the left-hand bottom of the screen climbing up. You want to give us an explanation of the lower right-hand corner of the numbers and letters there?
Yes, so
La
here
propulsion est normale.
Propulsion is normal, says the DDO.
So we have here the different tracking system, and as you can see, we have two different tracking systems. The one that we show is a TR1 is a radar,
Trajectoire nominale.
radar number 1, which is at Kourou, and CIS is the onboard system, inertial guidance system, which is the backup one. Whereas on the other system of control, because we have a dual system, we have the TR2, which is a radar number 2, and the BR1, which is a Bretagne 1. And the speed of the launch vehicle. Altitude is now reaching 57 kilometers altitude already, as you see, after barely 3 minutes of flight, and the speed is 2.13 kilometers per second. Be aware, 1 kilometer.
Calme.
Yeah, the guidance is quiet. That's what the DDO reports. And in terms of speed, 1 kilometer per second, remember that is
Extinction
3,600
du premier étage.
kilometers per hour.
All right, the first stage is just burnt out, says the DDO.
Séparation du premier étage.
And there's the first stage, separation.
So we are
La
now
propulsion du deuxième étage est normale.
And the second stage is burning with its one Viking engine. It'll burn about 2 minutes, taking Ariane to roughly 165 kilometers. You can see on the left there, on the left bottom of your screen, the cursor climbing up to Sep Quaff, the marker there. That's the separation of the fairing.
This separation will occur when the aerothermal flux, that is the friction of the air on the fairing, will be coming below specified value, which is in this flight roughly 1.1 kilowatts per square meter.
Separation's a little different for the first stage and for the second stage and for the fairing, isn't it?
Yeah, the criteria are different. In the case of the fairing, it's the aerothermal
Séparation
flux.
de la coiffe.
Okay, so from this point onward, the satellite is in the open emptiness, and it can continue flying like this.
Right, we're up at about 111 kilometers, which is why we can jettison the fairing now, because the fairing acts like a flying clean room for the satellite, which is not supposed to work under Earth conditions. It has to be protected from Earth conditions, but now we're above the atmosphere, and we can drop the fairing, which is 2 half shells of a carbon composite weighing some 700, 800 kilos, so which is more weight than we don't need.
So it's interesting to get rid of that dead weight. Yeah.
La trajectoire est normale.
Everything normal on board. Well, speed coming up, as you can see on the bottom, velocity, the V in the lower right, up towards 4 kilometers a second.
4 kilometers per second, which is 14,400 kilometers per hour. That's the speed presently.
The speed necessary for satellite separation is 10 kilometers per second, which
So
will be
there's still a long way to go, and that will be.
We're not
we'll
halfway.
see that later on the purpose of the third stage function.
Cursor climbing up on the lower left to SEP23. That'll be, of course, the separation of the second and third stages.
Station, but the third stage now is going to go a long distance since it's going to cross practically the whole Atlantic Ocean, and during that it will be tracked down by different stations. After Kourou station, we will have Natal station in Brazil that will acquire the launch vehicle, but with no specific event going on, but it will follow the launch vehicle. Then it will be
Acquisition par la station de télémesure de Natal.
there we are.
We've just been picked up by Natal, just over the border in Brazil.
Okay, and after another 6 minutes of flight, the Ascension Island station will acquire the launch vehicle, and this one should be able to track down the third stage engine cutoff, that is after its 13 minutes burn. But since it is very short, another station, Libreville on the African coast, will take
La
over
trajectoire est normale.
for this third stage engine cutoff and for the satellite separation. So you see we have a set of 4 stations that will track down the trajectory of the launch vehicle throughout the flight.
That overlap, because
And they all overlap so that we always have, even if one acquires or loses a little bit before or after the other one, we'll already have an information.
All right. You can see on the cursor on the left again, I keep coming back to this, it looks like the launcher is going to rise and then dip a little bit. We'll get to an explanation of that in just a minute, if you don't mind, Jean-Marc. But before we do, since we have a minute, I think it's time to go to the quiz. What do you say?
Yes, go ahead.
All right. The third stage is traditionally the quiz section of the broadcast. And Ariane Space quiz.
Tous les paramètres propulsifs sont normaux.
Question number 126. We mentioned we're using Ariane 42L tonight. Now what we want to know is how many Ariane 42Ls have we launched prior to tonight's launch? Again, question 126, the Ariane quiz. How many 42Ls version that we're using tonight have we launched before tonight? Now you start working, and we'll give you the answer in a minute. But before we do,
let's get back to that third stage.
Yeah, now why do we dip on the trajectory there?
Well, we will use the dipping effect to increase the speed and sort of rebounds to get then away from the Earth, because that'll be the start of the elliptic trajectory towards the substitute orbit, and this will help us increase the speed at a maximum level.
So it's normal. Very good. Now, we mentioned just very briefly in negative time before we took off that the satellite tonight, Galaxy 10R, has a couple of new items, a couple of things that we wanted to go into detail now that we do have the time. One of them is called the PVA, which is the perigee velocity augmentation, and you're going to tell us all about that. But it's linked with another one, which is called URS. So there's two things we have to know about.
So these two ugly names, as a matter of fact, concern the strategy of separation of the spacecraft. They are not actually built in the spacecraft, but they do affect it. We're going to see that. So the first one, the perigee velocity augmentation, consists in aiming at a slightly lower orbit than the so-called GTO transfer orbit. For instance, tonight, instead of aiming at the apogee of 36,000, we are going
which is what we normally
which is a normal GTO geostationary orbit level. We will aim a little bit lower at 33,000 something kilometers, which means that we need less performance to do that. In fact, we did that because the performance of the launch vehicle couldn't take.
Fin de visibilité de la station de télémesure de Kourou.
We've just lost visibility quite normally from the Kourou tracking station, the GDO says. We're now being followed by Natal only. Go ahead.
Okay, so as I said, the launch vehicle tonight, the 42L, couldn't take the Galaxy 10R with its
La
weight,
position est normale et la trajectoire est normale.
which is 3.5 tons tonight, right up to these 36,000 kilometers. So therefore, the idea is we send the spacecraft a little bit lower than the desired orbit, and then the spacecraft itself on the next perigee will increase its velocity to reach that 36,000. So you'll tell me, why didn't you do it with the launch vehicle? As I said before, because we didn't have enough fuel, and the satellite will take this fuel to do the same job, but it will not have to carry along with him the dead weight of the third stage and flight adapter. So it will be more efficient, and in the end, it will save some of his lifetime.
So, to resume, we put the satellite in a lower apogee orbit, and you could do this. You do this with a less powerful launch vehicle, but you also need a more complex satellite and ground system.
Yes,
I
of
imagine.
course. The satellite then has to have a reignitable engine, and it also has to have tracking stations on the ground that are capable to follow the spacecraft not only at its apogee level but also at its perigee. Of optimization. So to make something shorter, let's say that in order to guarantee the orbit that we give to the satellite, we have to put some extra propellant in the tanks.
Acquisition par la station télémesure d'Ascension.
We're just being picked up by the next downrange tracking station, which is Ascension Island in the middle of the Atlantic, a former NASA station, and now has ESA facilities there.
So coming back to our OS, if we can afford to have the standard probability like this, we want to achieve is 99%. If we are capable to accept that maybe with only 60% we can reach that orbit, we will save that fuel, and all this fuel which is saved will go into the spacecraft, so that either we reach the right orbit, which will still be in 2 out of 3 cases, and all this fuel will be years of lifetime more for the spacecraft.
So again, this is a customer decision?
Yes. Otherwise, if we are on the wrong side, it's a spacecraft itself that will use this fuel, but like for the PVA, it will need less fuel to do that than the launcher would have to because of its dead weight of third stage.
Okay, so less propulsion in the launcher and more propellant in the spacecraft.
And more lifetime for the
more
user.
lifetime. Okay, it's good for the satellite then. Now, URS and PVA is particularly beneficial when they're used together. And this is one of the rare times that we're using it together. The URS we have
That's the third time we are using them together, and 3 times we use spacecraft also.
The URS has been done 3 times. It was satellites flights 114 and 115, as we mentioned, the SatMix and PAS-6B, and also 125 Galaxy 11 last December again.
Which is all used spacecraft.
All Hughes.
So it's obviously definitely a strategy of the operator.
Right. So as long as you have a reignitable motor on your satellite, you can do this.
Yes.
All right. We have 5 minutes left, just under 5 minutes on the third stage burn. If you're following the cursor on the lower left-hand part of your screen, climbing up, you see to the mark X, H10. H10 is another...
extinction of H10.
H10 is the third stage.
And if you look at the box on the right side, you can see that as we are losing altitude, we're going down to 215 kilometers. Our speed is increasing to the good level. It's now 7.5 kilometers per second, which is roughly in the range of 27,000 kilometers per strategy. But he also has a new device, new since about a year or so, and this is the xenon propulsion system. Xenon is a gas and the propulsion is ionic propulsion. It means that we are in this spacecraft, the propulsion, the chemical propulsion is replaced by atomic propulsion, ionic propulsion. We're talking about particles of a very, very low weight.
3 minutes de propulsion et la trajectoire est normale.
But
three minutes of propulsion left in the third stage. Burn and everything is fine. This is electrical propulsion, an alternative to the chemical, more traditional.
Yes. So why do we go for this electrical propulsion? Because it is about 10 times more efficient in terms of ratio between the thrust and the weight of what has been used.
And what's it going to be used for on the satellite?
It's been going to be used to keep the satellite in its position, which is, so the inconvenience of this ion propulsion is that we have very low levels. So it can only be used if you have small corrections or if you have a very long time in front of you. But in order to keep a satellite in its position, which requires some small adjustment throughout the year, this is a perfect mode of propulsion.
Encore 2 minutes de propulsion.
It would also be an ideal mode of propulsion for long-distance trip in the outer planetary system that could go for months and months.
So we have using ZIP's xenon ion propulsion system means basically you're carrying fewer pounds of fuel, you have more life. I think the figures we had, you're carrying 200, 300 pounds instead of the normal, 1,300 pounds of the bipropellant, which is what they use.
Yeah, in kilos, say 100 kilos, 109 kilos of xenon instead of about 6-7 times more in if it would have been chemical propellant.
And there's another advantage that you're not working with volatile liquids, are you?
Well, we are working with the gas, but one thing is to say we're at the start of this, and in this new platform, HES-702, like the one we use on the Flight 125, the ratio of use of xenon in the new used spacecraft is about 10 times higher than what it is on this HES-601 platform tonight.
Yeah. Well, theoretically, they say it's more reliable. I think the jury is still out because it's a rather new system. There's not really enough experience, but...
It's getting...
with internet and telecom services for the company. The 27th satellite built by Hughes for PanAmSat, and the 15th launched by
Extinction du troisième étage.
Ariane. And there's the extinction of the third stage. And now we're going to move. We're going to move into an explanation of what's happening now before we have separation. But just before we do, to go back to the quiz.
Début de la manœuvre d'orientation.
We're into SCAR maneuver now. We're going to get back to what that is. But do you remember the question for tonight's quiz? How many 42 L's before tonight? Did you come up with an answer?
I think I got it. It's something that is below my number of fingers in my hand. Maybe 9 or something.
Maybe 9 or something. 9 is the correct answer. Just very quickly, go back to Flight 56.
Fin de visibilité de la station de télémesure d'ascension.
In 93, Astra, that was a Hughes-built satellite. Flight 67, 76 was pass 4, Hughes. 78 and 79, Telstar and an Astra, again Hughes. Flight 100, Intelsat. Flight 104, an Intelsat. Flights 114 and 115, we mentioned already, SatMex and Pass 6B, both Hughes-built satellites. So the answer is 9:42 Ls before tonight. If you got the correct answer, give yourself a pat on the back and call us up here in the booth at 35862, and Jean-Marc will send you a check for $100.
On your behalf, of course, Josh.
All right, SCAR maneuver. We are now in between extinction of the third stage and moving into satellite separation. Something's happening. What's going on up there?
Well, there's no
Poursuite
propulsion.
normale de la manœuvre d'orientation.
No propulsion anymore, but we are now going to orient the spacecraft, and in order to do that, of course, we have to orient the third stage as well, because the separation hasn't taken place yet. So we put the spacecraft in the right direction. That's
Fin de la manœuvre d'orientation.
which is now over. Then we start the spinning movement, because we're going to separate this spacecraft with a slight spin. This spin will be stopped then when we reach the geostationary transfer orbit. The body will be stabilized on 3 axes, but during this transfer movement it stays on a spinning movement. He hasn't deployed his solar panel yet, so it stays on the spinning movement.
That comes later.
That comes later.
You can see on the bottom velocity of the right-hand screen, we're approaching the 10 kilometers per second, which is the speed we need.
Right, yes, that is the speed we need, and now the speed, of course, since there is no propulsion, is going to decrease.
Séparation Galaxy 10R.
Separation of the spacecraft. That was the third step.
Coming. Let me tell you now that the satellite is separated, just briefly what is going to happen with the in-flight maneuvers, and then we'll get back to your contribution there. Yeah, the first pass, the first acquisition will be in Indonesia at Dan Mogo. I hope I'm pronouncing that correctly. That's in I think 36 minutes after liftoff or after separation. Yeah, you're right. The burns, the apogee burns, we'll come back to the apogee burns. We're going to the first replay now.
Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage. Décollage. La propulsion est normale.
All right, nice shots of the launcher as she took off about 20 minutes ago. Coming back to the in-flight operations of the satellite, over 5 days we'll have the apogee motors, starting from the 26th to the 31st of this month. Reflector deployment will come on February 2nd. Solar ring deployment the next day on the 3rd. And the testing from practically the whole month of February, from the 5th to the 28th, before the satellite Galaxy 10R will enter into service on the 28th of next month.
And regarding the launch vehicle itself, this mission has been ended about a minute ago by making a maneuver so that that third stage and the flight adapter do not follow the same track as the satellite. Like all third stage, they are being put on a sort of a parking orbit on which they will rotate for years ahead, but never encounter a spacecraft and their trajectory.
All right, while we're waiting for the speeches, we're going to hear from, I think, 3 people. We'll hear from Ariane's COO, Jacques Rossignol, and then Doug Kahn, the CEO of PanAmSat, and then from Randolph Brinkley, Executive VP at Hughes. While we're waiting for these gentlemen,
the possibility of service to the customer. And I could add also that this increased cadence.
We might go to another replay here if we get shots from Toucan. If we do, I'll just interrupt you. Go ahead. So
okay.
Here we go with the second replay.
Top. Allumage. Décollage.
The second replay from the Toucan site, which is a little closer to the launch base. Always spectacular shots. We're still waiting for the mics to be opened for Jacques Rossignol, Doug Kahn, and Randolph Brinkley to make their speeches. I can see them making their way out of the fishbowl. They'll be out here in the red VIP room shortly.
So to complete the program of this year 2000, I was just about to add, just before the replay, that we have initiated the construction of a new payload facility, processing facility, so that we can cope easily with 20 to 22 spacecraft a year, and not only spacecraft like we've seen so far of the Ariane 4 category, but also spacecraft that will be of the Ariane 5 category, that is heavier, larger, or even of a different type, like constellation of satellites.
There's plenty of upgrades going on the ground system. We'll get back to that in just a minute. Jacques Rossignol first.
Well acquainted with Douglas Kahn, who is chairman of PanAmSat. He was with us in December, he's with us in January, and Doug, I think that we are particularly proud of this launch. We knew it was critical for your company. This satellite is going to replace another satellite which was at the end of its life, and it was extremely critical that we be successful tonight. As we said this morning, it's not enough to have the best launcher statistically.
Well, Jacques, it's a pleasure to be back. Only 5 weeks after the last launch, and it's a pleasure to be back and have such a successful launch. Once again, 2 successful launches in a row. For us, this was a particularly important launch, and I thank you on behalf of PanAmSat and on behalf of the customers who are on the SBS-5 satellite, which ran out of fuel about a week ago and very much needed the satellite that was launched this evening. So we're extremely pleased. Over the course of the next 45 days, we'll be maneuvering this satellite into its final location, and we know that will go smoothly. And in March, we will expect to put the satellite in service. And of course, by the end of March, we expect to be back once again for the launch of our Galaxy 4R satellite. And with the wonderful service that we've gotten, we know that once again, we'll have a successful launch. And I'm reminded of the reason why we select Arianespace for so many of our launches. And there's really 2. One is the flexibility that you have shown to us in numerous circumstances in which there have been changes at the last minute, and Arianespace has been very responsive to those changes. And the other reason, of course, is reliability. And we know when we select you and we ask for your assistance, we will get it, and we will have successful launches like we had tonight. So it's wonderful to be back, and we look forward to seeing you again in just a few months. Thank you, Jacques.
Thank you, Doug.
And thank you, all the people of Arianespace.
Well, as far as we are concerned, our next rendezvous here will be on February 16 for a Superbird satellite, which will be also built by Hughes, as the 2 last launches were. So see you in a month from now, by the 16th of February. Have a good evening.
So Jacques Rossignol thanking PanAmSat for its confidence, and Doug Kahn very pleased, citing flexibility and reliability of Ariane, and looking forward to coming back for his next launch.
Pilotage est normal.
All right, so the plan for next year, of course, is roughly 13, 15 launches, roughly 18 spacecraft, 5 Ariane 5s. Starting the new year, as we mentioned, with a bang, keeping the same pace as 1999. PanAmSat this year will be launching Galaxy 4R with the Hughes 601 and Pass 1R, which will be the Hughes 702. 52 straight launches successful for Ariane now. 106 of the 172 operating telecom satellites up there launched by Arianespace. And the next launches, as Jacques Rossignol mentioned, was on February 16th with Superbird. Flight 128 mid-March is an Ariane 504, 3 months. Ariane 505, sorry, 3 months after 504. And then April a Galaxy, and in May PanAmSat. So that, I think, will do it from Kourou. For all of us, on behalf of everybody at the Space Center, Joshua Jample with my friend Jean-Marc Otto, saying thank you for listening, and we'll see you next time.